In this video, we'll be looking at the APM feature of XPack. This is the new Application Performance Monitoring component within XPack. Throughout this video, we'll be looking at what Application Performance Monitoring is. We'll look at how do we install the APM server and configure the APM server. I'll show you some example code that is using the APM client within our application, and then we'll dig through the user interface that's built into Kibana for APM. APM is Application Performance Monitoring. This is needed when you have an application, perhaps a web server or a data processing engine, and you need to find out what components of your application might be slow, might be called a lot, might be inefficient. So you can typically install an agent within your application, and that agent will communicate with some back-end service and report what is going on with that application. So in the case of the web app I'm going to show you, we have API endpoints, we have database interactions, and this APM component allows us to see what's happening and how long those interactions take. As of now, it's a pretty limited tool set that the Elastic APM agent can work with. But right now, it is Node.js applications, web applications, or Python web applications that use Flask or Django as their application. And the example I'm going to show you is a Flask-based API handler. So thinking about your application and how it's probably deployed in your environment that also has the Elastic Stack, you probably already ship your logs from that application to your Elastic cluster. And that's good. So you need to put your logs, you need to put your output into Elastic so you can see what's happening and troubleshoot your application. But in order to get the same visibility into timings and how long, downstream HTTP or database requests get, you'd have to put some pretty complicated timing code within your application, dump that to a log file, and then grok it or parse it and bring it into your Elasticsearch cluster. Well, the APM agent already does this. It wires in throughout your application to look at performance bottlenecks, to look at code that's called regularly. It will automatically store and log back exceptions, like full stack trace exceptions within your Python code or Node code. And then it'll also keep what I think is one of the most important components is seeing what dependencies are perhaps slow. So if you're interacting with a database engine or you're interacting with other web services or external applications of some sort, you want to see how long those take. So this APM will give you visibility into that. So I just came back from a conference related to Elasticsearch, or Elastic in general, and I talked to some of the developers on the APM platform particularly. Right now it is limited scope. It's a fairly early program, but and like I said, you can plug it in with Node or Python using Flask or Django. They are adding Java soon. Java support should be coming down the road. I'm not sure what kind of application will be needed, whether it'll be a Spring-based web application or Spring Boot or something like that. But Java is coming. Elastic as a company is extremely fast to development. They're rolling out releases regularly, so keep your eyes open. This should be updated soon. All right, let's go through a walkthrough. First, we'll log into our Linux server, and I'm going to show you how you install this application. So we downloaded this APM server from Elastic. And since this is a CentOS, Red Hat type machine, we can do sudo rpm-i APM server. Press enter, potentially give it your sudo password, and it will install. So I've already installed it here, but that's exactly how I installed it. So then we can edit the configuration file. So we'll go cd into etc APM server, and we'll open up apmserver.yaml. All right, so we have a few important things here. So APM server runs as an application, whether it's on the same Linux machine as your agent, or if you're using some distributed monitoring. APM clients can send data to a centralized APM server. The APM server then deals with the integration to Logstash or Elasticsearch. So we tell it what host to run on. So we can run on localhost or 00.0. Port 8200 is default. There's an experimental front-end application that's there now, but they say not to use it. The secret token. So if you want to start adding some authentication to your clients, you can do that here. You type in whatever secret key you want to use and then install on every application. Here's some configuration items. When the APM server starts, it'll send some mappings to Elasticsearch, telling Elasticsearch how to deal with the data that comes with the APM. And we have some dashboards that are set up into Kibana automatically. So we tell the APM server where your Kibana is running. Mine's default, localhost 5601. Again, you can be distributed here. And then we know we have an output of Elasticsearch. So this is going to send data straight to Elasticsearch. So now let's say we've configured that. We can make sure it's running. So I'll stop it just to make sure it's stopped. And it's stopped. And now we can run it. And we know it's running. Let's verify that it's running. Was it port 8200? So there we have APM server running on port 8200 listening. All right, so let's go back to our application that we built. So this code will be available for you in section 6, video 4, and we'll look at a few things. So first, for this application, I have a requirements file. This is a way you can tell your Python environment what libraries are needed for compiling and for working. So I have the requests library to make an HTTP request if I wanted to. Flask RESTful. So Flask is the application server framework. RESTful is a plugin that makes it easy to make API endpoints. And then we have the Elastic APM client that we'll install. So if we look at our Flask application, this is a standard Python application, so we'll go through it pretty quickly. We have our imports for JSON, logging, sys, and traceback. And here we have the Elastic APM component. So this Elastic APM application is specific for the Flask framework. We're also getting the logging handler from APM as well. So this logging handler allows you to write general regular log outputs, and they'll go to your APM server. Then we have things for Flask RESTful, and then SQLite. So SQLite is a very lightweight, basic database engine that you can use in a whole bunch of different applications. So what we did here is I set this up so that we can see that there will be downstream interactions and some things will be slower, faster, etc. So to build this, you follow the normal Flask startup. So Flask, you give it a name. The name is this application or this class file. You get a reference to that as app. Then you make an API handler for that app. That's the Flask RESTful package. The next part is where we're setting up our configuration for the APM. So we give a service name to our application. In this case, we'll call it Pact Fauerbach Faui Flask 2 because we're recording. Secret token, I didn't have one configured, so there is no secret token. And then the server URL of localhost 8200. Now here's the important part. You want to get a reference to APM because you wrap the Flask app with the APM application. So it's an Elastic APM application. All right, so here for my application, I'm making a connection to my users.db file, building a cursor. When I start up for the first time, I want to create a table for users. It's a regular database table, commit, and then I am selecting all the users from the database if they exist, and I'm keeping them in a dictionary, referencing them by ID. So you'll see here in my users dict, I'm setting the index of an integer of the ID and giving it a reference to this user from the database. So I have a few routes enabled. These are your APIs in the Flask REST library. So we'll give it a default route of / and we'll say hello world. We'll see that. We have a user list API, which I'll define the path to it down below, but basically they'll select star from the database and return all of the users that are in the database. And then we have a specific user API around the resource of the users. We can get parameters for name and description. And then we can, when we HTTP put a new user or an existing user to update, we will open the database, execute an insert statement, see the insert or replace statement for our database, and then we will update our users. And we have a whole bunch of logging information that might come back through our app logger, which you'll see at the bottom. We'll configure to use APM logger, and no HTTP delete for now. This is a lightweight application. So here's our mappings. API users to get a list of the users. API user / a number, an integer that we'll use as ID, is going to be an endpoint to get or post a specific user. Now when we start the application, we make a custom handler, which is a logging handler with a client of apm.client. That was the APM reference from above. We'll set our handler level of debug, so we want to see everything. We add it to the app logger, and then we run our application. So let's do that. We'll run Python Flask app. And we'll see a whole bunch of stuff come by. No error messages, which means it has connected to the database. So now you can see the table exists. So let's kill this and we'll start fresh. So we'll remove our users database, and we'll run the app again. All right, so now we've created that table, and it is time to test out our API. So I have a few, let's do this. I have a few helpers here. So I have a get script, which is calling that API user's endpoint to see everything. I should see all the users in my database, and there are none. Okay, great. So then I also have this create script, and the important part's at the bottom. Actually, I'll show you the whole script. All right, so from the start, we're going to use the random library more than anything else. We have a random list of names, a random list of descriptions. We're going to iterate from 0 to 1000 and assign that value to x. We'll get a random name, a random description, and we'll call requests.put. Remember that put creates or updates a user in our database. An API call to API user with an ID, so we'll use x as our ID. We'll pass a description and a name, and we'll print out the response. So this will run by pretty quick, and we'll see if I want to let it run the whole way to 1000. So it's running. And I'll let this run for a minute, and I'll stop when I feel like stopping. Okay, I feel like stopping. I'll hit Control-C, and that's not the important part. The important part now is when I call get, I get a big list of my users. So I got all 396 users with a green Lee and a happy George and a green sorry. Now let's jump over to the APM dashboard within Kibana.